Page 3 of T-Test. So the weights in kilograms of the 11-year-old boys and girls in grade 6 were recorded to find out whether the boys weighed less than the girls. So they're saying specifically they're looking to see if the boys weighed less than the girls. So let's say that the boys are mu1 and the girls are mu2. They're looking to see if mu1 is less than mu2. That's the alternative hypothesis. The null hypothesis, as usual, is mu1 is equal to mu2. State whether this is one-tailed test or a two-tailed test. This would be a one-tailed test because it's less than, right? Find the t-value and p-value for a t-test at the 5% significance level. So we're going to do stat, and we're going to do test. Oh, by the way, I put in the data into stat edit if you saw. And we do number 4. And we're going to put data L1, L2, 1, 1. We're going to put mu1 is less than mu2 because that's our alternative hypothesis in this case. Enter. And then the pooled is yes, and calculate. And our t-value is negative 2.56, and our p-value is equal to 0.0105, or 0.0105. And if we compare that to a 5% significance level, 0.0105 is less than the 5% significance level, 0.05. So that means we reject the null hypothesis, which means that mu1 is less than mu2. Okay, so the boys do weigh less than the girls. Okay, let's go to number 6. Our pharmaceutical company claims to have invented a new remedy for weight loss. It claims that people using this remedy will lose more weight than the people not using the remedy. A total of 20 people are weighed and tested. 10 people are given the new remedy and the other 10 are given the placebo. After 2 months, the people are weighed again, and any weight loss in kilograms is noted in the table below. Reading this problem, don't you think that when they do the COVID phase 3 testing with thousands of people, they are going to do a t-test to see whether or not there are significantly less people that did not contract the virus? In fact, I'm sure they did this calculation on the phase 2 test too, because I mean, if you have the data, you're gonna do it. You just won't publish it, right? Stat edit. Okay, so we're gonna put this data in to the calculator into L1 and L2, and then I'll be back in a second. So let's say that the new remedy is mu1 and the placebo has mu2. Write down the null hypothesis. The null hypothesis is that the mean weight loss for both is the same. And the alternative hypothesis is these are weight losses here. So the weight loss is going to be tested to see if the new remedy has more weight loss than the placebo. State whether this is a one-tailed test or a two-tailed test. One-tailed, right? Because they're looking specifically to see if mu1 is greater than mu2. Find the t-value and the p-value for the t-test at 1% significance level. I put the data into the calculator. We're going to do stat, test, and number 4, which is 2 sample t-test, data L1, L2, 1, 1, and then we're going to put mu1 is greater than mu2. Whoops. mu1 is greater than mu2. And calculate. T is equal to 2.84. P is equal to 0.0055 0.00339. Okay, and now we're going to compare 0.00359 to, oh, it's 539, not 359, to the 1% significance level. It is smaller, which means that we are going to reject the null hypothesis, which means that the new remedy works, right? mu1 is greater than mu2 is our conclusion. Okay, it's nice to write that in a sentence instead on the exam, instead of writing down math equations, but again, I am using a stylus, so that's why I'm writing it briefly. The lengths in centimeters of sweet corn cobs in the field on either side of the main road are measured to find out whether there is any difference between them. So that sounds like the null hypothesis is just not equal to, right? Okay. And then I'm going to put these two populations in the calculator. By the way, I don't remember if I mentioned, but when you fill this in the calculator, the easiest way to erase the list is to put the cursor on top of L2 and press clear. Okay, don't press delete because that will delete the list. Anyway, I'm going to type these in and I'll be right back. Okay, so is it a one-tailed test or a two-tailed test? It's two-tailed because we don't know if it's greater than or less than. It might be either one. We're not limiting it, so it's two-tailed. Find the t-value and the p-value for the test at the 10% significance level. As you can see, I did type in into L1, field 1, which is mu1, and field 2, which is mu2. And I'm going to figure out the p-value and the t-value by doing stat test option 4 and data L1, L2, and then we're going to go down, we're going to put mu1 is not equal to mu2, and then we're going to go down to calculate. And our t-value is 0.535, and our p-value is 0.600, and our p-value is pretty large. If we compare it to the 10% significance level, it's greater, which means we accept the null hypothesis. So there's no difference between the corn on both sides. They're equal to the means are equal to each other. And I think that's it. Yeah, that's it for this page. So that's it for t-test.